Hi there. I'm going to go ahead and finish up the notes that we were looking at on Friday so that you can then go ahead and do the assignment that goes along with the set of notes. And the thing we have to talk about is the rules or properties of integrals that we can use to help us calculate areas. We can use these anytime we want. They're definitely helpful for the geometry-based problems, but we'll see there's going to be multiple times where we'll want to use these properties. And this one, number one, is the first one, is probably the most important. It's probably the one we use the most. Is that if we have an integral from a to b of f of x dx, that we can rewrite that as the integral from b to a, as long as we switch the negative and put a negative in front. Okay. We have found that to be super useful when, and we already talked about this problem, but I'm going to talk about it again with you, when we are doing kind of the backward problem. So if we go to this problem in the packet, if we take a step back here, and I'm going to zoom in on this a little bit more. Woo! Okay. So when we were asked to calculate f of -5, that became the integral from -1 to -5 of little f of t dt. Okay, so starting at -1, start and going that way. Okay. In our typical thinking, in calculating areas using geometry, we are usually going left to right. So this problem is sort of backwards. Okay. Because we're going from a higher number to a lower number. Okay. Since -1 is greater than -5. Okay, typically a less than b is the forwards thinking part. So we can do this a couple different ways. We can say, okay, I'm going to change this to the integral from -5 to -1. And I'm going to put this extra negative in front of it. So that when I do that, sorry, I know I've moved my arrows and stuff. Kind of makes a little bit of a mess. Sorry about that. Let's just kind of erase some of this stuff here. Okay, so if we're going to go from -5 start to -1 end, this is going to be a negative, and this piece is going to be positive. So we're going to have the opposite of a -4 for that triangle, because that's 1/2 times 2 times 4. And then the trapezoid, 1/2 times 4 times 1 plus 2 is going to be 6. And so that's -2 or -2. We did talk about a second possibility. Right. In the second possibility, remember, you can always freeze this if you need to follow this, but in my second possibility, if I just want to go from if I don't want to rewrite this, and I want to go from -1 to -5, -1 to -5, which is some backwardness. That means the signs are going to reverse. And so the triangle will be +4, the trapezoid will be -6, will still come out to be -2. Most students like having left to right. They like lower to higher, and so if it's presented in the backward way, they will rewrite it. You don't have to rewrite it. You can think about it as it's given. It will still give you the same answer. All right. So we use that property a lot. Here are some other properties that we use. First of all, or next, I guess, integral from a to a is 0. Okay. If you think about that in terms of an area, if here's f of x, and we're starting and ending at a, basically there's no area to be covered. Third one, pretty intuitive, is that if you have from a to b of the sum or difference of two functions, that you can split it up and do it separately. You can go from a to b under f and from a to b under g. Okay. If you have an additional constant times the function, you can pull the constant out in the front, and you don't have to graph the transformation of f of x. You can just think about f of x and then multiply by c, okay. Including if you have a negative. I would say probably, other than the first one, these other ones we don't think about too much. We may do them, but we don't think about them. But number 5 is the one that's going to get used, and I've seen AP questions in this context, and saying, if we have a big area from A to C, we can break it into 2 smaller areas. We can go from A to B and then B to C, as long as where we end is where we start. Okay. That's the kind of, so if we end at B from A to B, then our next one goes from B to C, so we're covering the entire region. So here's 2 examples of problems we may be asked to do with this. We know that this integral is 19, and we know a part of it is 10. We're asked to find the other part of it. Now, when I'm focused on one of these problems, I'm always looking for the piece that's talking about the biggest range. So my piece that's from 0 to 12 is the biggest range. And then I have the 0 to 7 piece and the 7 to 12 piece. Okay. So that's the relationship I can create out of these 3 integrals, that whatever I have for 0 to 12, that's going to be the same for 0 to 7 plus from 7 to 12, as long as this ends at 7 and then this starts up again at 7 and I cover the full 0 to 12. Okay. And then this just becomes an equation to solve where I know that this is 19 and I know that this is 10 and I'm looking for this, so that's equal to 9. Okay. Now, sometimes I twist it around a little bit more. In this example from the AP exam, we have a 1 to 10 integral, we have a 10 to 3 integral, and then we have a 1 to 3 integral. Okay. 1 to 10 is the biggest one, so I'm going to focus on that. So 1 to 10 would equal, well, I can use the 1 to 3. But then this one would have to be 3 to 10. So this is the relationship that would be true. Now, if I look at the things I'm given, my 1 to 10 is 4. My 1 to 3 is what I'm looking for. And check this out. It's not 3 to 10, it's 10 to 3. So if 10 to 3 is 7, 3 to 10 would be the opposite. So 10 to 3 would be the opposite of 3 to 10. So if 10 to 3 is 7, the 10 to 3 part, 3 to 10 part would have to be -7, so they'd be equal. So the correct answer on this problem, and I apologize for all my writing kind of jumping around here. There we go. Is D. Okay. These are kind of fun. They're kind of like little puzzles almost. You typically have enough, you definitely always have enough information to figure it out. It's just you got to figure out kind of maybe how to configure the pieces to work together. So you'll see that the second half of the homework assignment is you practicing some of these problems. Okay? All right, guys. So check out this video and check out those problems, and we'll talk again on Wednesday. Have a good one.